All right, so the quiz will be made available right after class, right? As usual, you will have until Thursday, 12 o'clock. Check it out, but you have double check that. 12 o'clock to submit the quiz. I hope everybody gonna do it today or tomorrow, okay? So you don't have to wait until the last day to do the quiz. So it's gonna be, it's gonna cover all the chapter 3 basically. Like, each section will have a question on it. Okay, so we're gonna go ahead and continue. We're gonna just practice a couple of problems on the last section, 3.6, and then we're gonna open up, the last chapter of this class, which is chapter 4. All right, so we're gonna first share my screen. So, okay, I give you like, few problems right here. Solve x squared minus x greater than or equal to 42. Solve, okay. 4x squared 4x squared plus 8x over all right. I'm not gonna let you for each problem, like a couple of minutes for each problem, and then we're gonna go over them. Okay, everybody, please try to do that, everybody. All right. I think we can go ahead and try to. Who's gonna try to help us with the first one, please? Somebody.
Subtract 42.
You said you're gonna subtract 42, right? Okay, we subtract 42. All right, so we get what? We get x squared minus x.
Minus x minus 42, and you can simplify that, and that would be x, what, x plus 7 and x minus 6? Or x,
The other way around. It's x minus 7 and?
yeah, x minus 7 and x plus 6. That's what it was. Yeah.
Yes, exactly. Okay. So, okay, so now we put everybody to the same side, and then we factor if possible, right? After we factor now, what should we do next? And that's going to be the main step. After we factor, what we have to do next?
Set them equal to 0.
We set them equal to 0 to get the zeros, right?
Yep.
Okay, but after that, we have to do this. You see, on the quiz, I have to see this line right here. I have to see that. If I don't see that, if you just go ahead and write the answer and you don't put this stuff right here, where you put the two zeros, -6 and +7, right? And then you have to decide, you have to see when this expression is positive and when it is negative, okay? When it is positive and when it is negative, you have to do that. The sign chart, okay? For instance here, if I take 8, for instance, 8 here, if I plug in 8 here, it's going to be 8 minus 7, 8 plus 6, it's going to be positive, so it's going to be positive right here, right? Okay? And then between -6 and 7, what's going to be the sign, positive or negative? What sign I will get between -6 and 7? Positive sign or negative sign?
Negative.
It's going to be negative, right? Yeah, we have two ways to know it is negative. Either you test a number between them two. For instance, 0 minus 7 and 0 plus 6, that's going to be negative. Or you say that 7 is a cross point. Because 7 is a cross point, if this was plus to the right, it's going to be minus here. Okay? And again, why 7 is a cross point? Because the exponent is just 1. And -6 is also a cross point. If it is minus here, it's going to be plus here. Now, what is the sign I'm looking for? Greater than or equal to 0. What sign I'm looking for?
Greater than.
Or equal to 0. Positive sign, right? Which means my solution will be everywhere I see positive sign. It's going to be here and here. And then since I have equal, I'm going to include them too. So my solution will be -infinity to -6, union 7 to infinity. In the test or quiz, if I don't see this part, right here, I will not consider, if you just go ahead and write me the final answer, I don't see that part, I don't consider the work done. I will not give you no credit, okay? Because that is the work. That right here is the work over there, okay? You just cannot go ahead and just say, okay, we did something similar in class. The solution is -infinity is this, and then even if your answer is right, if I don't see the number line along with the signs plus, minus, etc., if I don't see that, I don't give you the credit. All right? Okay, for the next one, who gonna tell us the first step they did?
Factor the numerator.
Okay, so how you factor the numerator? What you gonna put out?
4x
4x.
4x times x plus 2.
Yep. Over x minus 3 less than or equal to 0. Right? Now what you do next here? Exactly the same thing we did. I put this, I put all my zeros. Now how many zeros I have now?
3.
I have 3 zeros, right? I have 0. I have -2. I have +3, right? So 0 comes from here. This one is -2. This one is +3. So now, again, that my work is not complete until I put the signs here. For instance, every 0 here is a cross point. Every 0 here is a cross point. If I check 4, which is here, just randomly, if I check 4, I put 4 times 4, you see, I put 4 times 4, parentheses, 4 plus 2, parentheses, over 4 minus 3. Everybody positive, 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 going to be positive, right? So it's going to be plus here. But since this is everybody is a cross point, it's going to be a minus, it's going to be a plus, it's going to be a minus, okay? Everybody see that? Now, what sign I'm looking for here? Because of this less than or equal to 0, what is the sign I'm looking for? I'm looking for the negative sign, right? It's going to be, so my answer will be this and this. Now, what number cannot be part of the solution anyway? Which number?
+3.
+3 cannot be part, so that's why I put an open circle here. And for these two, they are part of the solution because of the equal here. So my answer will be -∞, -2, union 0, 3. All right. The last one is a little bit different, not too much, but a little bit different. Do not multiply by the LCD. Do not cross multiply. Okay? If we have inequalities, we're going to avoid multiplying by any x's, okay? Because when you multiply by x's, it becomes very hard, right? So what you're going to do first, we're going to bring the 2 over to the left side. We're going to see 3 over x minus 1 minus 2 greater than 0, right? So -2 minus 2. Now, I'm going to view the 2 as 2 over 1, right? So I'm going to add these two. What is the LCD? It's x minus 1, right? I'm going to multiply by x minus 1, x minus 1. You see, I haven't multiplied the whole, I didn't multiply the whole stuff. I just multiplied the second fraction by x minus 1. I have right to do that. It's 3 over x minus 1 minus 2x minus 1 over x minus 1 greater than 0. What I get? I get 3 over 3 minus 2x minus 1 over x minus 1 greater than 0, right? Now I distribute, I get -2x plus 2. So it's going to be 5 minus 2x over x minus 1 greater than 0. All right, everybody? Now we get something that we recognize. Now we can do this. Put, how many zeros we will have? How many zeros we'll have?
2.
We'll have 2 zeros, right? What are they? They are, one of them is 1, right? What is also 0? What is the other 0? If I do 5 minus 2x equals 0, I got 5 equal 2x, and then I divide by 2, 5 over 2, right? Thank you. I know 1 cannot be part of the solution anyway, right? 1 cannot be part of the solution. Before I even focus on the 5 over 2, I know 1 cannot be part of the solution. Now, what are the signs? Plus, minus, plus, or minus, plus, minus, etc. What are the signs? For instance, if I take 0 here, 0 is here. I plug in 0, I get 5 minus 2 times 0 over 0 minus 1. This is 5 over negative 1, which is negative, right? So this is minus here. Since everybody is a cross point, it's going to be plus, and it's going to be minus, you see? So the sign I'm looking for is a positive sign, which means my solution is here. And I open both of them because I don't see no equal. So the solution is the interval 1, 5/2. All right. These are the type of problems you can expect to have on the test, on the quiz. Very likely, very likely, a problem like that one and a problem like that one. This one is less likely. Okay, but very likely a problem like this one and a problem like this one. You're going to see that on the quiz, and you're going to see that on the test. Okay, and you're going to see that on the final exam. Okay. All right. This closes chapter 3. See, in the chapter, what did we learn in chapter 3? Polynomials. From the quadratic polynomials, how to find the vertex, how to find the x-intercept, how to find the y-intercept of a quadratic function. And then we focus on the polynomials, how to find the zeros of a polynomial, right? How to use synthetic division, etc. And then we focus on rational functions, how to get the vertical asymptote, how to get the horizontal asymptote, how to get the x-intercept of a rational function, the y-intercept of a rational function, etc. And then finally, we focus on how to solve quadratic inequalities and how to solve rational inequalities like that. That is what we learned in chapter 3. Now, you will have test number 3 to check yourself, right? You will have test number 3 to check yourself. Do I understand this stuff, or something like that? Every section is represented in quiz number 3. Every section, right after class, you will see every section is represented in the quiz number 3. Okay? If you see the quiz number 3 and you are confident you can answer to all of these questions, all of them, you can answer to them, then you say, okay, I get chapter 3. If there is some of them you don't know how to answer, then you have to make sure you get help, tutoring. I'm always available for tutoring before we do the test. Remember, the quiz is only 5%, but the test is 15%. All right. Okay. So we're going to open up this one here, chapter 4, which is exponential and logarithmic functions. So we have already done, we already done 4.1. 4.1 was inverse functions. We already done that. No, we're going to go directly to 4.2, which is exponential functions. All right. What are the exponential functions? Okay, so look, a small introduction to that is, so this story about exponents, okay? Exponents, when they are simple, The definition is very simple. When they are nice exponents. For instance, all of us know what is 2 cubed, right? We all know that, okay? We know 2 cubed is 2 times 2 times 2, 3 times, right? Okay? You see, when the exponent is a very nice whole number, positive number, then the definition becomes very, very simple. Is 2 times 2 times 2. That's it. Now, let's make it a little bit more complicated. Let's say 2 to negative 3. Okay? You see, that one now, we don't say this is just, 2 times 2 times 2 negative 3 times, right? We don't say that. By the way, somebody knows what is the definition of this? How can we rewrite 2 to negative 3 power? Somebody knows?
Would it be 1 over 1 over 2 with negative 3 in the exponent, or
1 over 2 to the 3rd power. Thank you.
yes.
Right? You see, this here, we don't say this is 2 times 2 times negative 3 times. It doesn't make no sense to say that. But we can use a prior definition to define 2 to negative 3 power, right? And then we move to the next exponent, which is 2 to 1/3 power. You see, the rational exponent. We say, okay, this is cube root, okay, etc. But imagine somebody asks you what is 2 raised to the pi exponent. You see, the number pi itself is a problem, right? Let alone if you want to raise 2 to the pi power. You see how much this stuff is complicated? If I put it in a calculator, the calculator will give me the answer, but we cannot imagine how much math is behind that. This is not trivial. This is not like something simple. Because the exponent itself, the pi itself, is not like a regular number. This is an irrational number. This is what makes exponential functions non-trivial, because we allow the exponent to be any number. We allow the exponent to be any number. But if you want to allow the exponent to be any number, then we have to say we have to restrict the base. You see, for instance, do you have an idea how much this stuff is going to be? We have no idea how much this stuff is going to be. Because when we raise -1 to any power, we expect only a couple of answers. 1 or -1, right? But when you have -1 to the square of 2 powers, that is too much complicated. We say, okay, this does not exist. So exponential functions, right? We allow the exponent to be any number, but the base, the number that we are raising to some exponent, we don't allow it to be negative because, just to avoid problems. So when we say f of x equals a to the x power, right? That is an exponential for any real number x. Right? That makes sense only if a has to be positive, right? If a is a negative number, then the exponent cannot be any number. You see, if we allow the exponent to be any number, then we cannot allow a to be negative, because then it's going to be so much problematic, right? And a cannot be 1. The two stuff are different. The two reasons are different. We just explained why a cannot be negative. Can you give me a reason why a cannot be 1? Can somebody give me a reason why a cannot be 1?
Because the answer will always be 1.
Exactly. Thank you very much. If a is 1, it's going to be 1, 1, 1, 1, 1. Then it's not anymore an exponential function. It's going to be just a constant function. Okay, that's the reason. A, this is called exponential base A. This function right here is exponential base A. Okay, it is exponential base A. That is exponential function that you see here. All right. The A is the base. The base cannot be negative, and the base cannot be 1, okay? But the base can be any number that we want. For instance, what you say, f of x equal 3 to the x power. This exponential base what? Base 3, right? F of x equal 1 over 5 x. This is exponential base 1/5. F of x equals 1.076x. This is base 1.076, right? If I say f of x equal -3 x power, that is exponential base what? This is exponential base what?
No, we cannot have a negative number.
Thank you. Yeah, I want to trick you. This is not an exponential function, right? Okay. So for any number, for any exponential function, a to the 0 power is how much? And we always what? 1, right? So if you want to plug in exponential function, so we're going to see some example right here. F of x is equal to exponential base 2 of x, right? If you want to plug in numbers, you substitute the x, not the 2, right? You substitute the x, but not the 2. Okay, let's see what this going to give us. X here, f of x. 0, 1, 2, -1, -2. Go ahead. Let's do like, a couple of, few seconds to figure out the left column when you plug in those numbers.
Professor, I already finished. When you're ready, can I try and give the answers?
Yes, okay, let's give like, a few seconds for everybody else to try, and then you're going to give the answers, please.
Sure.
All right, go ahead, please. Give me how much is f of 0? When you plug in 0, you get what?
F of 0 is 1. F of 1 is, what is it, 2. F of 2 is 4. F of -1 is 1 over 2. And then f of -2 is 1 over 4.
Thank you. All your answers are correct. Thank you very much. So the one here is 2 to the 0 power is 1, right? 2 to the 1 power, of course, is 2. 2 to the second power, of course, is 4. And now 2 to the -1 power is 1 over 2 to the 1 power, which is, 1/2. And 2 to -2 power is 1 over 2 squared, which is 1 over 4. So when we graph this stuff right here, if you graph them, So 1, 2, 3, 4, 5, etc. Right? Okay, so f of 0 is 1. You have the 0.01. So you have 1, 2, 2, 4, negative 1, 1/2, negative 2, 1/4, right here. That is a graph of exponential base 2, right? Just, just to do a quick link between this and chapter, some of the concepts we have seen. This graph, what can you say about the line, the horizontal line, the x-axis? What can you say about it?
It's
Oh.
increasing.
It is. The graph is already increased, but the horizontal line, that line right here, what can we say about it vis-a-vis the graph?
It
is
a limit.
It is what?
A limit.
This is a limit, but what is the word we used in chapter 3?
Horizontal asymptote.
Exactly, horizontal asymptote. Because my graph, my red graph, will get close to that line, but will never reach it. Okay? You see, there is no number that you plug into exponential base 2 and you get 0. You see? You can get like very small numbers. You see, for instance, if I raise 2 to a very, very small number, a very negative number, if I raise 2 to negative 100 right here, if I do 2 raised to negative 100, my answer will be a very small number, but not 0, okay? It will not be exactly 0. So this horizontal line, y equals 0, is a horizontal asymptote, okay? So this is how the exponential function looks like when the base is greater than 1, right? When the base is greater than 1, the exponential function will be a function that is quickly increasing, right? That is a function that is quickly increasing. It's go up like very quickly, okay? It will never be negative. So the domain here, as you can see, the domain is negative infinity, infinity, and the range here is 0, infinity, okay? The domain is the whole x-axis. This is the whole x-axis is the domain, and the range is only the positive part of the y-axis, right? As you can see here, that is the range, okay? That is for exponential base 2. Exponential base now, let's say the exponential base 1/2 now. Exponential base 1/2. F of x equal 1/2 to the x power. Go ahead, do the same stuff here. X, f of x, 0, 1, 2, negative 1, negative 2. Please go ahead, fill up the right column. At least we see what number you're gonna find. All right. Okay. Somebody is ready to give us the right column? How much is f of 0?
One.
F of 0 is going to be always 1, right? Regardless. F of 0 is going to be 1. Is 1/2 raised to 0 power, which is 1. F of 1 is how much?
1/2.
1/2, right? F of 2 will be how much?
1/4.
1/4. Thank you. Now, f of -1, what do you think is going to be?
I'm not really sure.
Mm-hmm. How much is that? That you're not sure.
1/2.
You say 1/2? You see,
No,
if you want to
it's gonna
make this stuff become positive,
It's gonna be 2.
you just flip the fraction. 2/1 to the 1 power, which is 2. Okay? 1/2 to the -1 power is 2/1 to the 1 power. It is 2. All right? And 1/2 to the -2 power, how much is that?
4.
It's going to be 4. It's 2/1 to the 2nd power, which is 4. So when I do that, when I represent these points right here, I have f of 0 is 1 as usual. F of 1 is 1/2 like this. F of 2 is 1/4 like this. Okay. F of -1 is 2. F of -2 is 4. So I have a function which is like this. So basically, the basic graph of an exponential function can be of 2 types. One of the 2 types. It's going to be either increasing like this, going up left to right, or either decreasing like this, from going down from left to right. Okay, can somebody tell me when the graph will be increasing? If the base is what? If the base is
A whole number?
a whole number, I mean 2 is a whole number, of course, right? But there is a more accurate definition when the exponential function will be increasing, going up, if the base is greater than 1, right? Like 2, like base 2. Exponential base 2, the base 2 is greater than 1, the graph will be increasing. It's going to be less than 1, like this one, is the graph is going to be decreasing when the base is less than 1, when the base is a fraction between 0 and 1, right? Like 0.5, 0.6, 0.7, 0.2. Every time the base is less than 1, the graph will be decreasing. So we have 2 graphs of exponential functions. If you want to summarize it, we have both of them have the same y-intercept, which is 1, both of them. One of them will be always increasing like this quickly when the base is bigger than 1. One of them will be always decreasing like this when the base is less than 1. Okay? That is the exponential function, right? So now, if I ask you to do this graph y equal 2x plus 1, right? What you're going to do to this graph right here? This is a graph of 2x, right? This is a graph of 2x. If I want you to graph y equal 2x plus 1, what you going to do to the graph? How are you going to transform it?
Move it to the left 1.
Is it to the left?
Up.
Move it up, because of plus 1 is not the x. We didn't add we didn't add the 1 to the x, we added 1 to the whole function 2x. So we have to move it up 1 word. So move up 1 unit, right? Move up what? Move up the graph of 2x 1 unit. So this is the graph of 2x, right? That is the graph of 2x, and then you have to move it up 1 unit. So it becomes like this. Okay, this is 2x plus 1. Now if you ask now how to graph, if you ask now how to graph this now, y equals 2x plus 1. Okay, now how are we going to move it now?
To the left at the x.
Exactly, because now we added 1 to the x power, we added 1 to the input, so we have to move it left. Move the graph of 2x to the left 1 unit. Okay, so don't forget that. In case I don't ask graphing on you know, I will not ask about that myself on the test. But if you are doing Alex or something like that, you know, you can be asked about that stuff. Okay. Okay, so that was the exponential function. This is exactly the exponential function. Is it something new? Of course, it's not new. You know, I have 083 classes, and we do that. We do exponential functions. Okay, when you do 163, you do a little bit more than 083, and if you do 165, you're gonna do a little bit more. If you do calculus, you're gonna do a little bit more. But exponential functions, they are very, very, very occurrent in math. If you do math, you're going to see exponential functions a lot, right? You cannot escape from them. You're going to have to deal with them. Now, we have a very, very particular exponential function, a very particular base that we call the natural exponential. Natural exponential. Okay, it is an exponential which is very, very particular from its applications. It's not particular because of some math properties. It is particular because of its applications. Now, let me go ahead and show you that number, that base. It is the base E. Let me share my screen, my whole screen, right? So you can see, you see my calculator right here? Everybody can see my calculator?
Yes.
If I do this is E. If I do E to the 1 power, that is the E, that is the number E. You see, 2.71, etc., etc. That number right here, that number, the decimal part will never end, okay? The decimal part of that number never ends, and that number is called E, okay? That is E. The decimal part never ends and never repeats itself, okay? How you call those type of numbers? The decimal part never ends and never repeats itself. There is no repeating sequence. How we call them? They are, what is the word? They are what? Numbers like pi. They are?
Is it irrational?
Irrational. Thank you very much. They are irrational. They are very important in science. This number E that you see here is very important in science. Now, where the number E come from? If you do a little bit of calculus, for instance, if you do this in calculus, if you do, you can take your calculator. If you have this, you do 1 plus 0.0005 raised to 1 over 0.00005, right? If you do this right here. So if you do this stuff right here, let's try see. Let's see what number is going to give us. If 1 plus 0.00005, right, equals, and then I raise it to the parentheses 1 over 0.00005, right? And see, let's see how much we get. Do you see how close this number is to the e power? Everybody see that? This number is very close to this number right here, right? If I put them like side by side, they are very close, right? They are very close. You see that? There is the same until up to this point right here. You see 2.7182, right? They are equal 4 digits after the decimal. Okay, so the expression E come from there. The expression E is the limit. It come from when you raise 1 plus x. When you raise 1 plus x power to 1 over x as x approaches 0. When you do that, this number goes to E. The limit of this number is going to be E. Okay, now we are not doing limit stuff. I'm just introducing where the number E come from. Okay, okay, that is the number E. So now exponential, the natural exponential is exponential base E. That is exponential base E. What is the natural exponential? Is exponential base E. Base E, right? And is the f of x equal EX. Okay, but remember, E is a number. Okay, E is just a number. We just called it E, just like pi. Okay, so what is E to the 0 power? It's going to be 1, right? What is E to the 1 power? It's going to be E. What is E squared? I have to use a calculator to find E squared, etc., right? But it's just, these are just numbers. And look at your calculator. If you have a scientific calculator, look. Do you see E? E is right here. You see? That is E. If I want to do E squared, I do E squared like this, you see? E 7.389, etc., If I want to do E to the -5 power, I do -5, and then I put E, right? You see 0.0067. Just a number. E is just a number. That is what you call the natural exponential. It is in your calculator like this. You see it here. Okay? Because it's very, very important in calculus. This function right here is very, very important in calculus. If you do calculus, you're going to use this number a lot, this function. Okay, so when you graph it, when you graph e to the x, what type of graph you're going to have? You're going to have the red graph or the green graph? What graph you end up having, the red graph or the green graph?
The red one, I think. E.
The red one, exactly, because the E is greater than
1.
Exactly, thank you very much. So if we graph the function e to the x power, we'll have a graph like this, because e to the x power is great, because e is greater than 1, okay? That is the natural exponential. That is the natural exponential. All right? So that, that was a refresher from, from exponential functions, okay? We define them, this exponential function like this. This is a natural exponential. After defining the exponential functions, our next step would be to define the logarithmic functions, okay? Because they go together. Exponential functions and logarithmic functions, they go side by side, okay? And we're going to define them right now. Exponential functions and logarithmic functions. So now we're going to define what is a logarithmic function. For any exponential function, what is the domain of any exponential function? Is negative infinity, infinity. So the domain of any exponential function ax is negative infinity, infinity. And the range of ax is 0, infinity. That's always the case. We can plug in any number that we want in any exponential function, right? That is the domain is negative infinity, infinity. But the answer, the outcome will never be negative, never, even not even 0, okay? All right, so now logarithmic functions now. Okay, the same way square root is the inverse function of square, the same way cube root is the inverse function of x cubed, right? The same way exponential functions and logarithmic functions are inverse each other, okay? That is the same thing. So, for instance, you all know from 4.2, I mean, yeah, 4.1, if I have f of x equal to y, you see, x is an input, y is an output, right? If you use f minus 1, what's going to be the statement now? From this statement, what's going to be the statement for f minus 1? The inverse. What you going to say?
Y is the input and X is the output.
Thank you very much. Y becomes the input and X becomes the output, right? Okay, so now, when you look at the graph of exponential functions, look at the graph of exponential functions, all of them, all the graph of exponential functions. What test they pass? They pass what test? They pass the, do they pass the horizontal line test?
No. Yes.
The you know, the red one passes the horizontal line test, the green one passes, it doesn't matter, they all pass the horizontal line test, right? Okay. Any function that passes the horizontal line test, they are called what? Do you remember 4.2? We call them what? We call them, the word is a composed word, is a dashed word. We call them
one-to-one functions.
Yeah. So did you forget that? All right, don't forget that we call them one-to-one functions, right? Any function that passes the horizontal line test, we call them one-to-one functions. And if a function is a one-to-one function, they have what? They have an inverse, right? Any function that is a one-to-one function has an inverse function. So this is what happened to the exponential. Exponential functions, they pass the horizontal line test. So a positive, a not equal to 1, the function ax is a one-to-one function. because it is a 1-to-1 8-to-1 function, so it has an inverse function. And that inverse function is called logarithmic function base A. Function base A. Okay, that is the inverse function. So now look, if I do this, the exponential form, right? And here I'm gonna say what's gonna be the logarithmic form. Okay, if I do this statement, a to the x power is equal to y. In this form, my input is x, right? My output is a y. That is exponential form. What's going to be the log form? The log form will be the other way around. I say log. This is where we put the base. We put the base as an index, right? At the end of the G. Okay, don't write this. Don't write log G. See, don't write this, okay? The A has to be as an index, as a subscript, okay? It has to be below log base A. Now, who was the input? The X was the input and Y is the output. So it's gonna be log base A of Y. Now Y will become the input here, is equal to what? X is gonna be the output. Everybody see that? These two forms are exactly equivalent. They exactly mean the same thing. These two forms that you see, they exactly mean the same thing. If a to the x power is equal to y, then log base a of y is equal to x, right? So basically, the log form is a way to express the exponent. The outcome for the log is always an exponent. That is very important. This is always an exponent. Okay, the outcome for a log is always an exponent. All right, so now from here, we're going to try to learn this very important, how we go from one form to the other form. If I say 2 cubed is equal to 8, right? This is an exponential form, right? What's going to be the log form of this? It's going to be log base what? What is the base?
2.
The base is clearly 2, right? Of what? What is the exponent?
3.
3. So the exponent will be the output for the log, always. And it's going to be 8 here. If I see that, the base is clear. There is no confusion about who is the base. The base is always a number we are raising to the power, right? Okay, that is the base always. Now, if you are about to get confused between who's should be inside the log, who should be on the other side, remember this: the outcome for the log, the output for the log is always the exponent. Remember that phrase. The output for the log is always the exponent. If I do this, if I do 10, right? 10 to negative 2 power is 0.01, right? What's going to be the log form then? Log, what is the base? The base is how much?
10.
10 of what? What number I put here? What number I put here? Or to the right side? What I put to the right side?
-2.
-2. It will be on the right side, right? And it's going to be 0.01. Everybody see that? Okay. That is, we have to know what is the relationship, how to navigate from one form to the another one, how to navigate from the exponential form to the log form, and we're going to do how to navigate from log form to exponential form. We're going to do both of them. But now, at first, we said for exponential form, and here range. We said for ax exponential base a of x, the domain is negative infinity, infinity, right? And we say the range is 0, infinity. That's for exponential function. Now for the log, what's going to be the domain then? Because they are inverse each other for the log, what's going to be the domain? Can somebody tell me?
0, positive infinity.
Exactly, because they are inverse each other, so this one comes here and this one comes here. What that means? That means you cannot plug in a negative number into a log. If you say log base a of -5, let's try to do that with our calculators. Okay, you see my calculator, this is log right here. That is log right here. This is log base 10. We're going to come to that. If you don't see the, if you don't put the base, it is base 10. But doesn't matter. Just to make my point, let's do log base 10 of -1. You see? Do you see here what it say? Invalid input, right? We cannot plug in a negative number inside the log. Let's even try to plug in 0. 0 and log base of 0. You see, log of 0, invalid input. You cannot put negative numbers inside a log. You even cannot put 0 inside a log. This does not exist. And log base a of 0 also does not exist, right? These are undefined. All right. Okay, they are undefined. So when we come back Thursday, we're going to learn how to navigate from log form to exponential form, how to navigate from exponential form to log form, vice versa, right? And then, you know, we're going to see how to solve equations, logarithmic equations, how to solve exponential equations, etc., etc. Okay, and then when we announce the test, we will, if you have time, right, we will try to review for the test. I have put the review for the final exam on Brightspace. I think everybody saw that, right? The final exam, you see, right here.
I saw it.
Yeah, I mean, you have a bunch of problems, but you know, the final exam will be only 20 problems, okay? So that's the review right here. Okay.
How much time will we have for the final exam?
It's 2 hours for 20 questions. I think it's more
Okay.
than enough. Okay. I think because you know, since the pandemic, we changed. It used to be 25 questions for 2 hours face to face, but now we say 2 hours because we allows people. You know, we only do 20 questions because in the 2 hours we allow students to scan the papers, etc. Okay. All right. So, and when we have time after we're done covering all our lessons, we're gonna go over the final exam review, and we're gonna try to review for that. You know, it feels good to have little time left so we can review for the final exam to refresh memories, right? You see, I don't know how many of you still remember how to solve this, for instance, right? Absolute value inequality that we did in test number 1. Okay, I'm not sure, etc. All right, so the quiz number 2 will be open right after class 2:05. You will have until Thursday noon. Okay, let me double check that, the quiz number 2. Quiz number 3. All right, until November 18, 12 p.m. The submission right here, you see everybody, you assign, you submit your answer here, just like quiz number 1, number 2. Submit your quiz 3 here. You have until Thursday 18th at 12 p.m. to submit your answer here, right? All right, everybody. And I will soon upload the project. I will soon upload the project for you I will give you enough time to do the project. I just want you to take it seriously, right? I will give you at least like something like 10 days to do the project, okay? At least 10 days. That's just more than enough. But you have to take it seriously. You have to remember that is 10% of the grade. You know, if you want to get an A, you have to do everything. If you want to get a B, you have to do good on the project, right? If you are struggling and you want to just pass the class, you still have to do the project. If you don't do that, it's going to be some wasted point. Okay. All right, everybody. Do you have any questions? All right. So please don't forget to do the test. Please, everybody, don't forget to do the test. All right. I mean, to do the quiz. If you have 2 days, you cannot say I forgot about it. All right. See you Thursday.
See you Thursday. Have a